Hello. Hello. Can you hear me? Hello.
Yes, sir.
Okay. Is the slide visible to you?
Yes, sir.
Is the slide visible to you? Hello.
Yes, sir.
Slide is visible to you, right?
Yes, sir.
Okay.
Yes, sir.
So let me wait for
Sir,
one
दिख
more
रहा
minute.
है.
Let me wait for one more minute so that people can join. Then
हाँ,
I will
sir, not
start the
visible.
lecture. So far, three of them have joined: Preetam, Nidiju, and Shayan. Whosoever is joining, you can unmute yourself. If you are joining, you can unmute yourself.
Yes, sir.
Okay. Okay, four of you have joined, so I'll not waste time. Let us start the class. Okay.
Yes, sir.
I think in the last class we have derived the expression for velocity and acceleration of the follower when it is moving with uniform acceleration and deceleration. Yes or no? Hello.
Yes, sir.
Yes, sir.
That
Yes,
means
sir.
this diagram we have discussed when the follower is moving with uniform acceleration and deceleration, what will be the displacement diagram, what will be the velocity diagram, and what will be the acceleration diagram. We derived the velocity of the follower, we derived the acceleration value of the follower, as well as we derived the maximum velocity and acceleration in this case. Fine. So next what we'll be doing is that we will be solving one problem based on this concept, that is when follower is moving with uniform acceleration and deceleration. Let us solve. Read the problem. A cam is to give a following motion to a knife edge follower to raise the follower through 30 mm with uniform acceleration and deceleration. What is this 30 mm? What is this 30 mm?
Sir, head H.
Yes, follower height is given to you, that is 30 mm with uniform acceleration and deceleration during 120-degree rotation of cam. What is this 120 degree?
Theta.
Not theta, it is phi A, angle
हाँ
of
जी, अच्छा
ascent. You
अच्छा
can call it as theta A or phi A. See, it is raising.
अच्छा
Raising condition means ascent condition. That means angle of ascent is given to you. Phi A is 120 degree. Theta means overall angle of the cam. Fine.
हाँ
Next is
हाँ.
dual for next 30 degree of cam rotation. What is this 30 degree?
So no movement.
No movement.
मतलब
That means
कोई.
dual condition, and dual we
हाँ.
represent by angle delta. That means delta 1. Delta 1 is given to me as 30 degree. Delta 1 is given to me as 30 degree. Fine. Third one is to lower the follower with simple harmonic motion during next 90 degree of cam rotation. What is this 90 degree?
Phi 2.
ID.
Phi
ID.
2. But remember one thing, in this question, follower is raising through uniform acceleration and deceleration, and the follower is lowering through simple harmonic motion. That means in the displacement diagram, for the ascent case, I will use the concept of uniform acceleration and deceleration to draw that displacement diagram, and for the descent case I will use simple harmonic motion concept to draw the displacement diagram. Is it clear?
Yes, sir.
Because in the last problem both ascent and descent was occurring with simple harmonic motion. In this problem the first part, that is ascent part, is with uniform acceleration and deceleration, and the descent part is with simple harmonic motion. So there will be a change in the displacement diagram. Keep it in mind. Fine. Okay, let us read the problem. The cam has a minimum radius of 30 mm. Radius of the cam is given to you as 30 mm and rotates counterclockwise. CCW means counterclockwise at uniform speed of 800 rpm. That means n is given to you. draw the profile of the cam. Draw the profile of the cam if the line of stroke of the follower passes through the axis of the cam shaft. From this line, I came to know that in this problem, axis of the cam shaft is not offset. Yes or no? Hello? Hello?
Yes, sir.
In this
Yes, sir.
problem, axis of the camshaft is not offset. If you remember the first problem which we solved, axis of the camshaft is somewhat offset. So here we have taken that offset length, and from here we have drawn that small circle, we have drawn the tangents, and my cam was starting from here. But in this question, it has been written clearly that line of stroke of the follower is passing through the axis of the cam. That means no offset thing we will take into account. Fine. Okay. Also draw the displacement, velocity and acceleration diagram for motion of the follower for one complete revolution of the cam, indicating the main value. Fine. Okay. First step is, let us draw the displacement diagram. You know how to draw the displacement diagram. You have to take two scale. One is linear scale and another one is angular scale. Say I am taking linear scale, say 10 mm is equal to 1 centimeter. Then this 30 mm is equal to 3 centimeter. Similarly, I am taking, say, 10 degree is equal to 1 millimeter for angular scale. Then in that case, this 120 degree will be equivalent to 12 centimeter and this 90 degree will be equivalent to 9 centimeter. Yes or no? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Fine.
Yes, sir.
So first step is, I will draw this height, vertical height, which is nothing but height of the follower lift 30 mm. Then from this point, I will draw infinitely long horizontal line. From this point, I will draw infinitely long horizontal lines. Now on this horizontal line, my angle of ascent as well as dual angle as well as angle of descent will lie. Fine. It has been told that angle of ascent is 120 degree. I have taken that angular scale 10 degree is equal to 1 centimeter. So 120 degree will be equivalent to that much centimeter. So that means from 0.0 to 0.6 is how much? 12 centimeter. I will cut an arc. Again from this point, I will draw a vertical line, 6. That means done. Then from 6 to this 6, there will be no movement of the follower. Angle of dual is 30 degree. If I have taken angular scale 10 degree equal to say 1 centimeter, so 30 degree will be equal to 3 centimeter. That means this horizontal distance 6 to 6 will be 3 centimeter. After that, angle of descent is coming, that is 90 degree. Since 10 degree is equal to 1 centimeter angular scale, so 90 degree will be equal to 9 centimeter. That means from 6 to this 12 distance is 9 centimeter. You got this point 12. Fine. From this 12 again draw this vertical line and you can complete this rectangular box. So far it is clear? Hello?
Yes, sir.
Yes,
So
sir.
far it is clear?
Yes, sir.
Any doubt? Fine. So since we have drawn
Yes, sir.
this 6 line and 0 line, now in order to get the cam profile minimum, whether it is angle of ascent or it is angle of descent, we have to divide it into minimum 6 number of equal parts. Now this length, that means this 12 centimeter length, again you have to divide into 6 number of equal parts. These are the vertical lines, 5, 4, 3, 2, 1. Similarly, this length, which length? This 5D length, angle of descent 90 degree. Again you have to divide it into 6 number of equal parts, vertical directions, 6, 7, 8, 9, 10, 11, 12. These things I have explained in the last lecture also. Is it clear how to divide this 1, 2, 3, 4, 5, 6?
Yes, sir.
Yes, sir.
Clear?
Yes,
Next,
sir.
that
Yes,
means
sir.
again in this case, this distance 0 and 1 and so sorry, this distance 5, 6 is not equal to 6, 7. 5, 6 will be more, this 6, 7 will be less. Why less? Because this angle is less. Why more? Because this angle is more. Yes or no?
Yes,
Hello?
sir.
Yes or no?
Yes, sir.
Fine. Okay.
What,
Next.
sir?
Next, what I will be doing is that, see, it has been given in the problem that for angle of ascent, follower is moving with uniform acceleration and deceleration. And I know for uniform acceleration and deceleration how to draw the displacement diagram. I have to find the middle point of the follower. Middle point is nothing but this third vertical line. Now I have to divide this third vertical line again into 6 number of equal parts. Fine. Then I will name it as say 1, 2, 3, 4, 5, 6. I will join all these points with the starting point 0 of the follower. That means 0 to 1, 0 to 2, 0 to 3, and I will extend it to 6. Similarly, from this 4 to this 4, from the and from the top middle part, I will join these 3 points with this point 6 dash. That means 4 to 6 dash, 5 to 6 dash. For 6, no need to do, already it is joined. Yes or no? And the intersection point, that means intersection point of this vertical line 1 and this inclined line 1 will be your point 1 dash. Similarly, intersection point of this vertical line 2 and this inclined line this 2, it will be your point 2 dash. Likewise, you will get 3 dash, 4 dash, 5 dash, 6 dash. Yes or no? Hello?
Yes, sir.
Fine. Next, from this 6 dash, from this 6 to this 6 dash, I will do nothing because there is dual. Dual means no motion of the follower. Again, it has been given in the problem that from this 6 to this 12, angle of descent is 90 degree. But during descent period, follower is moving with simple harmonic motion. And when the follower is moving with simple harmonic motion, I know how to get that displacement diagram. Now this is that follower height. I will take the half of the height. I will take in my compass. I will place my compass at the center point. I will draw this semicircle. Fine. Then again I will divide this semicircle again into 6 number of equal parts. That is 6, 7, 8, 9, 10, 11, 12. Each equal part is equal to 30 degree. Then I will drop the horizontal projection lines. This is 6. This is that point 6 dash. From 7, I will draw a horizontal projection line till this vertical line 7. This will be that intersection point 7 dash. Similarly, from 8, I will draw a horizontal projection line till this vertical 8th projection line. That will be your point 8 dash, and so on. If you will do like this, you will get point 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Now, freely you have to join all these locus points. Once you join 0, 1, 2, 3 till 6, here no movement, so straight line. Again from 6 dash, you will join it freely till this 12. Now this diagram is your displacement diagram for this problem. First part is with uniform acceleration and deceleration, and second part is with simple harmonic motion. Is it clear? Any
Yes,
doubt
sir.
in displacement diagram?
Yes, sir.
Fine.
No, sir.
Next, I need to draw the velocity as well as acceleration diagram also. I know that when follower moves with uniform acceleration and deceleration, that means when a particle moves with uniform acceleration and deceleration, velocity will be a linear curve. It will be a linear curve, and I will get maximum velocity at the midpoint of the follower. That we derived also. How I will get this value? This I will get the value from the equation which I have derived. I will put all the values in that equation. I will get this value, maximum velocity. Similarly, I have to find the maximum acceleration when the follower is descending, but this time with simple harmonic motion. And I know that when a particle moves with simple harmonic motion, velocity versus time graph is nothing but a sinusoidal curve. So this is a sinusoidal curve. How I will get this maximum velocity? I have the formula for that maximum velocity. When the follower moves with simple harmonic motion, I will put everything in that formula. I will get these values. Likewise, I will get the acceleration values also. And then I can plot this graph. Yes or no? Hello? Hello? Is it
Yes, sir.
clear?
Yes, sir.
Fine.
Yes, sir.
Yes,
Okay.
sir.
Now, after drawing these things, next, what is the step? Next step is I have to draw the cam profile. How to draw? Again, you know, first what I will do is that I will draw this follower height given to me in the problem, that is 30 mm. Then what I will do, radius of the cam is given to you. You will take that radius in your compass. You will place your compass at the center point, and your length will be nothing but this distance from the center point to this knife edge point, and you will draw this circle. Done. Now in the given question it has been told that axis of the cam passes exactly from the center of the circle. Now you have to divide this circle 3 times. First time you will divide it into, say, how many degree? For angle of ascent 120 degree. This is your 120 degree. This angle is 120 degree. Next is your dual 30 degree. This angle is 30 degree. Next you will divide it circle into this 90 degree part. Then from dual this part is 90 degree. Is it clear? See,
Yes, sir.
Yes.
I am having my circle. This is that knife edge point. Fine. This is that center point. I will take this much length in my compass and I will draw that 120 degree angle. This is 120 degree. Again, I will align my compass with this length. I will draw my 30 degree angle. This angle is 30 degree angle of dual. Again, I will align my protector with this end and I will draw that 90 degree. This angle is 90 degree. Is it clear?
Yes, sir.
Now, since I have divided my displacement diagram into 12 number of equal parts, so I have to divide this ascent. This is ascent, this is dual, this is descent. Again, this ascent into 6 number of equal parts. Dual, I will not divide anything. Again, for angle of descent, I will divide it into 6 number of equal parts. Yes or no? Yes or no?
Yes, sir. Yes,
Fine. That means, see,
Yes, sir.
like
Yes, sir.
1, 2, 3. Likewise, I will do it for 6 parts, and for descent also 1, 2, 3. Likewise, I will do it for 6 parts. Clear?
Yes, sir.
Done. And
Yes, sir.
then,
Yes, sir.
and then on the circle, I will mark the points as 1, 2, 3, 4. That means this point will be 1, 2, 3, 4, 5. Likewise, this will be 6, 7, 8. Likewise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Done. Now, I have on these extended lines, I have to mark distances. Which distances? From the displacement diagram. First point is 0. This point is nothing but the starting point, this 0 of the cam profile. Next is I need to locate point 1 dash. Distance is 1, 1 dash. This much distance I will take in my compass. This is that one line. On this one line, I will place my compass at this point 1 and I will cut an arc. This will be my point 1 dash. Yes or no? Hello?
Sir. Yes, sir.
Yes,
Fine.
sir.
Likewise, if I want to get this point 2 dash, that means I will measure in my compass this length, 2 dash length I will measure in my compass. I will place my compass at this point 2. This is that central line passing through 2. On that central line, I will cut an arc of length equal to 2 dash. This is your point 2 dash. Likewise, if you will follow the entire process till point 12 dash, now you got all the locus points. At last, use free hand to join these locus points. You will get your cam profile. Is it clear?
Yes, sir.
Any
Yes,
doubt?
sir.
No, sir.
Fine. Next step is what? Next step is I need to get these values, because in the question it has been told that you have to draw the velocity and acceleration diagram. If you want to draw the velocity and acceleration diagram, definitely at some point velocity will be maximum, at some point acceleration will be maximum. How I will find out? I already derived the formula. I know I am having those formulas. Fine. Omega is what? 2 pi n by 60. N is given in the problem. You will get the value of omega. And I have derived that when the follower is moving with uniform acceleration and deceleration, maximum velocity is given by 2 into h into omega by phi. Since I am talking about ascent period, this phi will be nothing but phi a. But remember, this phi a, you have to convert it into radian. Once you convert, you will get the value of maximum velocity as 2.399 meter per second. Similarly, you can calculate the value of maximum acceleration. formula I already know, that 4h omega square upon phi square. Since this is the case of angle of ascent, so I will use phi as phi a. You will solve, you will get the value of maximum acceleration as 191.97 meter per second square. Similarly, for descent period, you have to use maximum velocity and maximum acceleration, but this time the formula which you will be using, that will be for simple harmonic motion, and you will get the value of maximum velocity and maximum acceleration. Is it clear?
Yes, sir.
Any doubt?
Yes, sir.
Any doubt?
No, sir.
Fine. Very simple problem, very easy problem. It can come in exam for 15 marks. Hardly it will take 15 to 20 minutes to draw. Means you will take time, it will take time on this part and it will take time on this part. Remaining thing is calculation. So it will take around hardly 15 to 20 minutes and easily you can get 15 marks. Clear? Any doubt?
लेकिन आपको सिर्फ 10 मार्क्स में ही आएगा सर.
हाँ मतलब 10 मार्क्स में ही आएगा. अभी तो जैसा रूल हो गया है तो 10 मार्क्स में आएगा, फिर कोई दिक्कत नहीं है. ठीक है, कोई डाउट है किसी को?
नहीं सर.
फाइन. नेक्स्ट.
No, sir.
ओके, तो फिर next we are left with 2 more topics. That means last 2 topics of CAM. After that we will end the chapter. Fine. And मैंने आपको बोल ही दिया है ऑलरेडी कि लोअर पेयर में मैक्सिमम थ्योरी पोर्शंस है. उसके लिए आप रतन का देख लेना, रतन में कौन सा चैप्टर दिया हुआ है लोअर पेयर, वहां से आप पढ़ सकते हो. ठीक है. हेलो हेलो हेलो
उसका
हेलो
होगा
कोई
रतन
हाँ
का
बोलो. हेलो
रतन का सारा टॉपिक पढ़ना होगा
रतन
लोअर पेयर में.
का सारा टॉपिक जो न्यूमेरिकल उसमें 2 पोर्शन न्यूमेरिकल पोर्शन है, वो मैं बता दूंगा नहीं तो क्लास में. इजी न्यूमेरिकल है, फॉर्मूला बेस्ड न्यूमेरिकल है. बस तुमको फॉर्मूला पता होना चाहिए, तुम न्यूमेरिकल तुम तुरंत सॉल्व हो जाएगा. 2 लाइन का प्रॉब्लम आता है, वो 10 मार्क्स में तो नहीं आएगा, आएगा तो 5 मार्क्स में आएगा. मैक्सिमम बेसिकली उस पार्ट से जो थर्ड जो वो टॉपिक बचा हुआ है लोअर पेयर, उसमें मैक्सिमम मींस 70 to 80% इज थ्योरी.
सर तो इस बार तो सारा एग्जाम न्यूमेरिकल बेस्ड ही होगा, तो थ्योरी ज्यादा
अभी
नहीं.
मिड टर्म तो न्यूमेरिकल होगा, लेकिन एंड सेम में आ सकता है थ्योरी. मैं पूछ सकता हूँ दैट व्हाट इज एक्सप्लेन योर पैंटोग्राफ. 5 मार्क्स में, 10 मार्क्स में डायग्राम बनाना है आपको. पहले आप कॉपी में डायग्राम बनाओगे, उसके बारे में लिखोगे 5-6 लाइन लिख के, उसी को तुम अपलोड कर दोगे.
सर आपका नोट्स नहीं है उस
लोअर पेयर
टॉपिक
का
पे?
नोट्स अभी मेरे एक्चुअली क्या है, वो तो थ्योरी वाला पोर्शन है पूरा, इसलिए उसका नोट्स मेरे पास है नहीं.
सर,
अगर बनाऊंगा भी तो मैं उसी से ही
बता
बनाऊंगा.
देना।
क्या बोलते हैं, तुम्हारा लोअर पेयर से ही मतलब तुम्हारा जो रतन का किताब है ना, वहीं से ही बनाऊंगा.
सर,
सर क्योंकि बुक में
जो
तो बहुत सारा टॉपिक दिया हुआ है.
हाँ मैं तुमको वही बोल दे रहा हूँ ना. तुम लोअर पेयर में थ्योरी पोर्शन देख लो, जो न्यूमेरिकल पोर्शन देखने का जरूरत नहीं है, ओनली थ्योरी पोर्शन. पैंटोग्राफ क्या है, फिर तुम्हारा इंडिकेटर जो हम लोग गाड़ी में यूज करते हैं ना, ऑटोमोबाइल में जो इंडिकेटर
हाँ
यूज
सर.
करते हैं, वो मैकेनिज्म क्या है, मतलब उसका 4-5 लाइन का एक्सप्लेनेशन और एक डायग्राम.
ठीक है
सर लोअर पेयर से कौन सा पढ़ना होगा, अब टॉपिक बता देना थोड़ा.
न्यूमेरिकल छोड़ के तुम देखना जो बुक है और थ्योरी एसएस रतन, थ्योरी ऑफ मिशन एसएस रतन, न्यूमेरिकल पोर्शन छोड़ दो.
तो बहुत कुछ है.
हाँ अच्छा मैं बता
थ्योरी में तो
दूंगा.
बहुत कुछ है. कौन सा
सर
topic?
आप एक क्वेश्चन पेपर बना के दे दीजिए ना सर, जो थ्योरी क्वेश्चन आ सकता है ऐसा कुछ दे दीजिए.
अच्छा ठीक है, मैं उसको बाद में बता दूंगा क्या उसमें क्या पढ़ना है. ठीक है, लेकिन उसमें थ्योरी पोर्शन
हाँ,
है,
तो
न्यूमेरिकल
अच्छा.
पोर्शन नहीं है. ठीक है, चलो आगे बढ़े टॉपिक पे. हेलो हेलो
हाँ सर.
आगे
हाँ
बढ़ते
सर.
हैं. third part is when follower is moving with uniform velocity or constant velocity, then what is the change in the displacement diagram, what is the change in the velocity, and what is the change in the acceleration diagram, and lastly we will draw the cam profile. Fine. Okay, we know that from our engineering mechanics that when any particle moves with uniform velocity or constant velocity, displacement versus time graph is a linear curve. Yes or no? Hello?
Yes, sir.
Displacement versus time graph is a linear curve. And since velocity is uniform, you will get a constant value of velocity. And I also know that when velocity is uniform, When velocity is constant, acceleration is 0. Why 0? Because rate of change of velocity is acceleration. Velocity is constant. So differentiation of constant is nothing but 0. Acceleration is 0. Is it clear? Hello? Hello?
सर और एक बार बोलिए.
What I am telling is that when any body is moving with uniform velocity, then from the physics, 11th class physics or mechanics, what I have studied that displacement versus time graph is nothing but a linear curve. पढ़ा है कि नहीं मैंने? जब भी कोई बॉडी यूनिफॉर्म वेलोसिटी से मूव होती है, डिस्प्लेसमेंट वर्सेस टाइम ग्राफ इज अ लीनियर कर्व. ठीक है? And since velocity is uniform, you will get some constant value of velocity. So velocity will be velocity versus time graph will be a curve parallel to x-axis. देखो, ठीक है? And if the velocity is uniform, acceleration will be 0. Why 0? Because rate of change of velocity is acceleration. dv by dt is acceleration. Since velocity is constant, rate of change of means d by dt of constant is 0. So acceleration is 0. दिख रहा है डायग्राम में? Fine. That means when follower is rising, that means follower is undergoing a motion. Which motion? Uniform velocity motion. So you will get a linear curve. But when during the dual period follower is undergoing no motion, so curve will be constant. Displacement will be constant. No fluctuation in displacement. Again, when the follower is returning back to its original position, but this time displacement is varying linearly but in downward direction. Again, at this point, again, if there is any dual motion, see, there is no motion of the follower, and this cycle will repeat. Y-axis is displacement, x-axis here is not time, but it is cam angle theta, which is nothing but combination of rise, dual, return, dual. Fine. Next is velocity. Now see, since velocity is uniform, if the velocity is uniform, initially velocity cannot be 0. You have to give certain velocity to the body, then only your velocity will be minimum. Then only your velocity will be uniform. So see, there is a certain velocity given to this follower, so that follower should move with uniform velocity. This is that velocity. Again, during the rise period, since it is velocity is constant, see, velocity is constant. Again, at the end of the rise period, velocity will come back to 0. Why? Because here dual is occurring, and in dual velocity will be 0 because follower is undergoing no motion. Again, after the dual period, when follower is returning back, this time again follower is attaining some velocity, but this time follower is attaining velocity in negative direction, and this velocity is exactly equal to this velocity. Why negative? Because it is returning back. Again, it is coming back. Curve is falling down. Again, from this end to this end, velocity will be uniform. Why uniform? Because follower is undergoing uniform velocity motion, and since the velocity is uniform, you will get a constant value of velocity. Again, at the end of the return period, velocity will be 0, and this cycle will be repeated. Is it clear, this velocity diagram? Hello? Hello?
Yes, sir.
हाँ सर क्लियर.
Is the velocity diagram clear? Fine. Next is acceleration. See, I know that rate of change of velocity is acceleration. Since velocity is uniform during rise, during dual, and during return, so acceleration has to be 0. Why 0? Because formula itself is telling you that rate of change of velocity is acceleration, velocity is constant, rate of change of constant is nothing but 0. See, during rise, acceleration is 0, during dual, acceleration is 0, during return, acceleration is 0, again during dual, acceleration is 0. But see, at the initial point, at the start point, you are giving certain velocity to the follower. If there is a certain velocity to a follower, definitely there will be an acceleration. Yes or no? Hello? Hello? Definitely there will be an acceleration. This is, say, velocity v equal to 0. This is, say, velocity v is equal to 100 meters per second. That means suddenly you are jumping from 0 meter per second to 100 meter per second. That means you have to give a sudden jump to the acceleration. You have to accelerate. You have, for example, if you are say driving a bike, fine. At the start point only, if I tell you that start the bike at 50 kilometers per hour. Practically it is not possible, but theoretically, yes, practically it is not possible. But think like that you are starting the bike at 50 kilometer per hour. That means this is 50 kilometer per hour. If the velocity of the bike is 50 kilometer per hour, you have to give maximum acceleration. Then only it can attain at the start 50 kilometer per hour velocity. Yes or no?
Yes, sir.
Yes, sir.
That means acceleration has to be infinite. Because for some problem it is 50. For some other problem it can be 100. It can be 1000. That means acceleration has to be infinite at the start and at the end point, whether it is rise condition, whether it is dual condition, or whether it is return condition. Yes or no? Hello?
Yes, sir. Yes, sir.
Yes or no? But practically
Yes,
it
sir.
is not
Sir, yes.
possible. But practically is not possible. Acceleration cannot be infinite. Acceleration has to be a finite value at the start and at the end point. होगा कि नहीं होगा? Acceleration तो infinite नहीं हो सकता. यहाँ पे तो मुझे कोई particular, अगर velocity 50 किलोमीटर पर आवर है तो acceleration की कोई ना कोई एक value यहाँ पे मिलेगी मुझे. यहाँ पर भी मिलेगा, यहाँ पर भी मिलेगा, हाँ या ना?
हाँ, सर.
मिलेगा. अगर मिलेगा, then I have to change this displacement diagram somehow. If I can change this displacement diagram somehow, then only my acceleration will be in finite range. How to change it? So this is that changed diagram. This is your modified displacement diagram when the follower is moving with uniform velocity. That is actual displacement diagram. And this is ideal displacement velocity and acceleration diagram when follower is moving with uniform velocity. This is actual displacement velocity and acceleration diagram when follower is moving with uniform velocity. What is happening? See, in order to keep this acceleration value finite, this value, this value, this value, and this value. If I want to get this finite value of acceleration, see, I am getting these values only at the corners. So in displacement diagram, at the corners, I have to change this displacement diagram. How to change? See, at the corner, I am introducing a parabolic curve. Again, this is the corner where at the end of the forward motion of the follower, I am introducing a parabolic curve. This is the end motion of the dual period. Here I am introducing a parabolic curve. This is the end motion of the descent portion of the follower. Here I am using a parabolic curve. Why I am using a parabolic curve? Why not some other curve? Because from the experiments, it has been observed that parabolic equation gives the finite value of acceleration gradually. That means धीरे धीरे आपको acceleration को बढ़ाना पड़ेगा. So parabolic curve will give you that acceleration value to a finite limit gradually. And that parabolic curve will ensure that your velocity which you are, that means at the start point, see here velocity is sudden. This is 0, this is 50 km per hour. But if you use parabolic curve over here, your velocity will increase gradually. 0, 5, 10, 15, 20, then 50. Are you understanding the difference in the ideal velocity, ideal diagram and the actual diagram?
Yes, sir.
Fine. So that's why here in this diagram velocity is sudden, but due to introduction of this parabolic curve, velocity is not sudden, it is gradually increasing. And when the velocity gradually increases, you will get a certain finite value of acceleration at the start point, at the end point during ascent period, similarly at the end point during dual period, Similarly, during the end point during descent period of the follower. Is it clear? These displacement
Yes,
and
sir.
velocity diagrams. Fine. Okay. Now let us derive. What I need to derive? I need to derive the formula for displacement and velocity. Since acceleration will be zero, so no need to derive. Fine. How to get this displacement and velocity? Let us solve. Say, since when the follower is moving with uniform velocity, let the follower displacement is nothing but denoted by symbol y. That means y is nothing but a function of cam angle displacement theta. Y is nothing but a function of cam angle displacement theta. That means y is equal to some constant into theta. Fine. If I am talking about this period, which period? Rise period. During rise period, assume that follower rise is nothing but height h. That means in place of y, I can write h. So h is equal to c. During the rise period, angle of ascent is say phi a. Angle of ascent is say phi a. Let us, I am denoting that angle by angle phi. Angle phi is nothing but the angle turned by the cam during the rise period. Fine. So I can replace this theta by this symbol phi. Yes or no? Now I can write this equation as C is equal to h upon phi. Yes or no? I can write this equation C is equal to h upon phi. Now this expression, which expression? C is equal to h upon phi. I can substitute the value of C in this original expression. Let us substitute. What value I will get? I will get y is equal to C. C is nothing but h by phi into this theta, into this theta. Y is equal to h into phi by theta. This is that expression. This is this expression. I am replacing here displacement y is nothing but s. This height of the follower is h. Theta is the overall cam angle divided by phi. Now phi will vary. For angle of for rise case it will be phi a. For return case it will be phi d. For dual case it will be delta 1. Fine. I also know what I know that displacement is equal to speed into time. So angular displacement theta is nothing but equal to speed into time. So I can write this expression as s is equal to h into displacement theta. Displacement is speed into time. Speed is angular speed. That means omega into time taken is t divided by phi. Now if I differentiate this displacement with respect to time, I will get the value of velocity. So velocity v is equal to ds by dt. That means d by dt of s. S is nothing but h into omega t by phi. H into omega t by phi. Fine. Here I can take out h omega by phi outside the bracket. Fine. Let us take out h omega by phi. Then d by dt of t is 1. So the final formula for velocity becomes h omega by phi. And this is the maximum velocity. This is the maximum velocity by which the follower will travel, and this is constant. Why constant? Because in the question it has been told that follower is moving with uniform velocity. That means this value is nothing. This value from the y-axis is nothing but h omega by phi. Is it clear? Is it clear? Hello?
Yes, sir.
Any doubt?
Yes, sir.
Any doubt?
No, sir.
Simple. Fine. Now, if I want to calculate, say, acceleration, say you don't know that whether acceleration will be what. So, rate of change of this velocity is acceleration. That means dv by dt. dv by dt is acceleration. d by dt of velocity. Velocity is what? H omega by phi. H omega by phi. You can take out h omega by phi out of the bracket. Let us take out h omega by phi outside the bracket. Fine. D by dt of constant is what? 0. So acceleration is 0. If acceleration is 0, see here acceleration is 0. Rise case, dual case 0, return case 0. Is it clear? Hello.
Yes,
Hello.
sir.
Fine.